All right. This first example is probably going to take up about half a page. Maybe not that much, but it depends on how big you write your integrals, I guess. Suppose that f and h are continuous functions and that, this is the part you're going to want to write down, the integral from 1 to 9 of f of x dx is equal to -1. The integral from 7 to 9 of f of x dx is equal to 5. And the integral from 7 to 9 of h of x dx is equal to 4. Use the rules in the table, which the table it's referring to is what we just wrote down as the properties, to find each integral. So they give us, I'm just going to do them one at a time, but 6 different things they want us to find. So first is the integral from 1 to 9 of -2 f of x dx. So I want to look and see, based on what they gave me, if anything is similar to it, and then see what I need to do to figure it out. So I have an integral from 1 to 9, so that would be this one here, of f of x dx. But I have a -2 here, but according to the property, I can take that out and get -2 integral from 1 to 9 f of x dx. Now I can use this here. They told me that that is equal to -1 to get -2 times -1, which is +2, and that would be my answer.
Would that be using the constant multiple?
Yes. Because k can be any number, positive or negative. Kind of just write the negative one that I wrote for you, because some people think that, like, they don't realize that, like, negative is just, like, -1.
Yeah.
I can't go up to the constant multiple part, see if I copy that.
Did you write it wrong?
I think I did. I forgot the other negative.
Oh. Yeah, so it just comes out from there. All right, B, the integral from 7 to 9 in brackets of f of x plus h of x dx. So any ideas what I'm going to need to do to solve this one? Sum and difference, so I can split them up. So this is going to be the integral from 7 to 9 of f of x dx plus the integral from 7 to 9 of h of x dx. And that's just going to be equal to 5 plus 4, which is 9. Nice and easy. C, we have the integral from 7 to 9 in the bracket 2 f of x minus 3 h of x dx. So what all do we have going on here?
Well,
Isn't there like
there's
constant multiple
and there's
subtraction?
Yeah, constant multiple and subtraction. So just to not have to write so much, I'm going to do this in one step. Okay, so I'm going to pull the 2 out and the 3 out. So I'm going to do what I did in the last step, but I'm going to have a number out front, basically.
okay.
So this is just going to be 2, the integral from 7 to 9 of f of x dx, minus 3, times the integral of h of x dx. So then that's going to be 2 times 5 minus 3 times 4, which would just be negative 2. Are we okay on that since I did that all in one step? Good. All right, D. The integral from 9 to 1 of f of x dx.
We use our order of integration. Is it just
We'll just take a negative out and flip it.
Yep, so we're going to put a negative in front and flip it by using the order of integration. Yeah, I'm saying that because you're saying take a negative out, and I don't want you to think that every time you take a negative out that you flip it. So, yes, but yes, we put a negative out front, and we can flip it. So from 1 to 9 of f of x dx, and that would be negative. Oh, and that's negative 1, so negative times negative 1, which is just positive 1. E, the integral from 1 to 7 of f of x dx. This might require you to use something I gave you in a slightly different form.
We have to use the additivity thing.
Yes, we're using additivity, but we're going to be using subtractivity instead. Okay, it can also work the other way. Okay, so I want 1 to 7. Okay, but I have 1 to 9 and I have 7 to 9, right? Those are the different ones I'm dealing with. So I'm going to use the integral from 1 to 9 of f of x dx. Then I'm going to subtract off 7 to 9, because then that leaves me with 1 to 7. Okay, so the rule works the same way, either way. So this is from 7 to 9 of f of x dx. So 1 to 9 is negative 1. So negative 1 minus 7 to 9 is 5. So this would be negative 6. So while it's not explicitly written, it works, like the process works the same way. If we want to find something that we're not given exactly, we can manipulate it like that. F, the integral from 9 to 7 of h of x minus f of x dx. I would probably go step by step on this one so we make sure we get everything that's happening. What's the first thing that we know?
We have to flip.
Can you can break it out?
What?
Can you sum
We have
Sum and difference? Is that what you're saying? Yeah. So I'm going to go ahead and write it that way. So leave the integral as it is for right now. So the integral from 9 to 7 of h of x dx minus the integral from 9 to 7 of f of x dx. Now what do I need?
your order of integration?
order of integration, so I'm going to put a negative out front of both. However, this is going to give me 7 to 9 for h of x with obviously the negative out front. But when I put a negative out here, what happens?
It becomes a positive.
Becomes a positive, so plus the integral from 7 to 9 f of x dx. Which then is negative 4 plus 5, which is just 1. Aren't you glad we just did one whole problem?
Wow, what's
Mhm.
Not hard.
I think we're gonna stop there because we probably won't get through the next one.
Okay.
That's just.
Anyways, we should finish the section tomorrow, though. It's not a lot left.